Hey guys, it's Murray here. So I want to talk to you a little bit more about heat transfer. Okay, so I did some things with you yesterday, kind of talk about some things you should really kind of already understand with phases of matter. Now I want to talk to you about heat transfer. So I want you to imagine this idea. You're at a campfire and you've got this rock, and you take the rock after that's been sitting right in the fire, you pick it up with some tongs, you throw it into a bucket of water. What's going to happen? The rock's going to cool down. Water's going to heat up. At some point, they're going to come to equal temperatures. Okay? Now, if I ask you, how much heat did the water absorb? You'd have to think of a few things. First of all, the rock. How large is the rock? Okay? What was that rock's initial temperature? Okay? And if you think of it from the water side, you say how much heat is the water going to absorb? Well, it's going to tell them on how much water was in the bucket. What was the initial temperature of the water in the bucket? And then something called specific heat. We're going to talk about that. I'll talk to you a little bit more about that. This idea that I'm going to talk about specific heat now is the amount of heat required to raise a temperature of 1 gram of substance by 1 degree Celsius. In other words, if it was at 23 degrees Celsius, it goes up to 24, it's changing by 1 degree Celsius. It's an intensive property, so you learn that much earlier in the year. As I say, you don't need all the material present. Also, with intensive properties, we know we can identify a lot of substances. Okay, so we take that rock, drop it into that bucket of water, it heats up, but the amount of, this is one of the big ideas here, the amount of heat transferred from the rock is equal to how much heat is absorbed by the water. They have to be equal, okay? Don't forget, when I say that, we're assuming that there's no loss in energy, which is not really the case, okay? So let me just kind of show you what I'm talking about here. I have a bucket of water. I have 600 grams of water, okay? And it is at an initial temperature of 23 degrees Celsius, okay? I also have a piece of iron, okay? That piece of iron is at 900 degrees Celsius, okay? That's a complete estimation, okay? So, this heat transfer idea, this is what I'm talking about. So this is the model that I want you to have in your head, okay? So, I take the piece of metal, and I transfer it to the water, okay? What happens to the water? It's getting warmer, okay? Water's up to 35 and still climbing, okay? What happened to the metal? It cooled down, okay? At some point, they're both gonna come to equilibrium. So, my water rather, is now at 37 degrees Celsius. My metal, okay, is at 37 degrees Celsius also. They come to equilibrium with one another. Don't forget, I assumed that there was no heat transfer, which should be no loss of heat from the metal. Not 100% true. That's the model I want you to have in your head. So things will transfer between substances, okay? And the next thing I'll talk about with you will be specific heat. Thanks for listening, guys.
Do your chores without asking.